Hello, this is Lawrence Master speaking in for Post University Software Engineering 1 class, CIS 303. We're in Unit 2 this week, and we are talking about the exciting topic of modeling the process lifecycle and software project management. So, let us start from the beginning. What is a process? Okay, we introduced the process in Unit 1's lecture. A process is basically a series of steps involving activities, constraints, and resource to produce an intended output of some kind. Okay, process involves a set of tools and techniques. What's the meaning of process? It imposes consistency and structure. It gives us guidance and control and allows us to capture our experiences. Okay, these are critical things of a process. In terms of software process models, what are some of the reasons for modeling a process? We're trying to form a common understanding. We want to identify inconsistencies, and we want to tailor our general processes for a particular situation. In terms of software, we use something called a software life cycle. And what that means is when the process involves building a software product, the process may be referred to as that. And that typically goes through in a rough order of requirements analysis, systems architecture and design, program design, coding, testing, and system delivery. There are a number of software development processes that help us in having a general blueprint, and some of the ones that we'll be talking about are the waterfall model, the V model, the prototyping model, operational specifications, transformational models, phased developments, spiral and agile methods. Okay, so let's start to step through some of these processes. The first one, the classical view, is the waterfall model. It is one of the first process development models proposed, and it works well for well understood problems with minimal or no changes to the requirements. It's simple and easy to explain to customer, and it presents a nice high level view of the development process. Each major phase is marked by milestones and deliverables, and this view over here does a pretty good job of explaining why it's called waterfall. As you can see, if you imagine a mountain with water falling off from top to bottom, it linearly and sequentially goes from requirements analysis all the way down to acceptance testing and operation and maintenance. Okay, now some of the issues that we find in the waterfall model is that we have no iteration, and the reality of it is that most software deployments do apply a number of iterations. You may go to requirements analysis, to system design, to program design, and back to requirements analysis. And then you may go back to system design, program implementation, and go back to requirements analysis, and any infinite number of combinations thereof. So the first model, the waterfall model, is a rather simplified view of the software engineering process. And as noted here, it provides no guidance on how to handle changes. It views software development as a manufacturing process, i.e. going from one point to the next, rather as that back and forth creative process. As we mentioned, there's no iterative activities, and there are typically long waits before a final product is produced. So what we could do is we could bump up the waterfall model with prototyping, and that's kind of my version of what I call the waterfall plus plus, where we have a prototype, and it's a partial developed product, and it helps assess alternative design strategies, and it's useful for verification validation. This is a good example. This is a good pictorial representation of it. Notice here that with prototyping, if we inject prototyping, we can go ahead and prototype at any of the requirements analysis, systems, or program design level, and bump it back up to that module. And then when we get to system testing, we can go back and look at requirements analysis. Okay, another variation of the waterfall is called the V model, and it uses unit testing to verify procedural design. And that idea is exemplified here, where in acceptance testing we validate requirements, and we can verify the design as well, and system design and system testing. So with prototyping models, what we do here is we allow repeated investigation of the requirements or design, and it reduces some of the risk and uncertainty in what you're delivering. So you're really giving your customer a review step as you go along, which helps to avoid some quality control issues later on. Another type of model we have is something called the phase development model. And what we're doing with that model is we are pursuing a phase development in increments and iterations. And the advantage of that is we can have shorter cycle times and have a system delivered in pieces. And this diagram here does a pretty good job of explaining it. What we're doing is, instead of delivering this one mega product to the end user, we are breaking that product up into various releases. So after we build release 1, we'll give it to the users to use, and it'll be use release 1 in production. And then while the user is using it in production, we can go ahead and build release 2, etc. And that's how a lot of programs are indeed built. The Windows operating system is probably a great example, or any major operating system, where it is built in increments and iterations for users to use, and then what happens is the manufacturer goes back and improves on that. Okay, so in terms of the software process models, we have incremental development, and that starts with a small functional subsystem and adds functionality with new releases. And you can see that here in this picture here, where we're building up our solution in pieces. And iterative development is where you actually provide the customer with a product, and then you go ahead and make changes to different pieces of that. Now, phase development is desirable for several reasons. I mentioned training can begin early, markets can be created early, frequent releases allow developers to fix problems, and the development team can focus on different areas of expertise with different. Now, on to some of the latest theories and processes called agile methods, and we have various flavors of that. But basically, the emphasis is on flexibility and producing software quickly and capably. The Agile Manifesto involves valuing individuals' interactions over processes and tools, customer collaboration, and concentrating on responding to change rather than creating a plan and following it. Now, some of the examples of the Agile process includes Extreme Program, also known as XP, and that is one of the more popular Agile methods. With Extreme Program, the emphasis is on the concept of agility, which is communication, simplicity, courage, and feedback. And we have a lot of continual interchange between customers and development, and selecting the simplest design or implementation. Some of the facets of XP includes the planning phase, small releases, using simple design, refactoring, using coding standards, pair programming, and continuous integration. Now, moving on to project management applied to software engineering, I need to say that most of your general project management techniques work very well in developing medium to large software projects. Concepts such as the Gantt charts, activity diagrams, and work breakdown structures are used extensively in software engineering. For example, tracking progress, in your project schedule, what you typically do is you go ahead and try to figure out different phases of your project. Each phase will have some steps and associated activities with each step. And so your project development can be separated into a succession of phases which are composed of those items. And to understand that concept, just think of building a house. When you build a house, your first phase is to prepare the site, to survey the land, request permits, excavate. Then you go ahead and buy materials. And then after you lay the foundation, you build the outside walls, install the exterior, electrical, plumbing, etc. So in much the same fashion, you can lay out the milestones in a matrix, and you can develop an activity graph of building a house. Now, you can apply these same concepts towards software engineering. And one of the most important tools in project management regarding software engineering is the Gantt chart, where you lay out your phases, your steps, and your activities with associated timelines. And this is a pretty good example here. Note, you can mark what steps have been completed, which paths are in the critical paths, and where you have slippage. So that's it for Unit 2. Some of the key ideas in this unit included understanding the process development activities, understanding that it uses resources, the process model, which includes organizational, functional, behavior, and other perspectives, and understanding that a process model is useful for guiding team behavior, coordination, and collaboration. Some of those ideas that we talked about include the V model, the waterfall model, etc. And some of the key concepts in project management uh, apply very directly to software engineering, include project planning, cost schedule estimation, team organization, and risk management. Remember, your project planning needs to get input from all team members. And finally, more does not mean better. Remember that as you throw more resources and more people into the mix, the communication path will grow, and that needs to be taken into account in planning and estimating schedule. And that concludes my presentation for Unit 2. Thank you.